So my screen has been shared with you all. Is it visible to all of you?
Yes.
Screen? Okay. Let me tell you first of all, what is this class all about? So first of all, we have studied in unit number 1, introduction to 8086 and 8051. In unit 2 is all about the concept of 8086. The unit 3 is all about 8051 microcontroller. This is microprocessor. Unit 4 is all about the interfacing. Interfacing of what? Interfacing of 8051 with keyboards, LEDs, and so many devices. So, okay, and all about unit 5 is advanced microcontroller. This is clear, I think. This must be clear to everybody. Advanced microcontroller. So अगर तुमको याद हो, if you remember that कि while studying this microprocessor, we have studied all the concept in class. Whatever concept has been discussed in class now, that concept was visualized through the software that is called EMU 8086. Whatever concept we have studied in microprocessor now, that was visualized by this software. Similarly, in unit number 3, we have studied microcontroller. So whatever concept till now we have studied in 8051 will be visualized through Keil software. So whatever we have done in this EMU software, similarly we will do in the Keil software. But the problem is very simple. The problem is that EMU software is very easy to handle. This Keil software is little bit tricky, or there is a setup procedure to use this Keil software. Similarly, for unit number 4, in order to see or visualize this interfacing and microcontroller, we require both Keil software plus Proteus. These two things are required to understood the interfacing and microcontroller. Whatever program we write in Keil now, from there we generally get hex file. That hex file is required in Proteus to visualize this situation. Hope this much is clear to everybody. Yes or no? Please let me know. Anyone?
Yes, sir.
Good. So now today we are going to I tell something about the Keil software. So from the starting I am going to tell you. So please look what I am doing, what you need to do. So first of all, I will be closing this part. Okay, let me close. My desktop screen is visible to everybody.
Yes, sir.
So now, first of all, I am going to this Keil Microvision 5. This is my Keil Microvision. I am going to press this Keil Microvision software. So one screen will be coming, right? So first of all, whatever is written here, don't see. The first step is go to the project. While going project, new micro, every time you need to do all these things. There is no shortcut to this. Everything, whenever we are going to write some program on the Keil, you need to do this. So first of all, create new microvision project. So when you press this now, so this type of screen will be visible to you. So first of all, whenever we write some programming Keil now, it will ask to save that file and make sure that whatever you are going to do now, make a folder of that, because for that program now, you all the files which will be generated during that program now, that will be shared somewhere. So it is better to give a name to that folder. So right now I'm going to give the folder name 11 p.m. uh, B111. Hope you understood. So this is the folder name I am going to give. So now I'm going to open, and here I'm going to write, we are going to write the first project. So this will be demo 1. So now I'm going to save this project. So now whenever you save this project now, one screen will be visible like this. In this screen, you have to select the microcontroller. How you are going to select the microcontroller? First of all, see in this search region now, I am going to print 89C51. What is 51? 51 is the microcontroller. And see, if you see, this is the 8089C51. Why you have chosen this microcontroller? This will be understood if you read all those things. Because whatever we have studied in class now, 8051 microcontroller we have studied, and this microcontroller is similar to that microcontroller. So if you see this 8089C51, all these things are basically written here. So we are going to use 8051 microcontroller, which has been studied in class only. So now just after selecting this, just press on the OK. Now it will again ask for the yes or no. What is the meaning of yes or no? When you type yes now, that means you are intended to write a program in C. In C also you can write a program. In this you can write a program in assembly language also. But what we have studied C or assembly language. So we have studied assembly language. So for that case, we are going to put no. No means assembly language. S means C. So I'm going to press no. So when you do this now, what will happen? See, project demo one. Within the project demo one is basically a target. Now, after doing all those things, if you see this screen now, this screen is gray. You cannot write anywhere anything here. If you want to write a program, this is the space where you write a program, but you cannot write a program. So one more thing you need to do for that. After this, just go to file.
But
Yes,
your screen is not visible.
a key is not visible.
Yes, sir.
Why? Screen is not visible.
Sir, visible, sir.
Sir, it's visible.
No, sir, not visible.
For whom it is not visible?
Sir, it's visible.
Visible, visible.
No, sir, it is not visible.
Visible, sir.
ठीक है, जिसको दिख नहीं रहा है इसका मतलब उसके इन पे प्रॉब्लम है।
क्या नेटवर्क इशू हो गया होगा सर?
हाँ, नेटवर्क इशू होगा ना, तो कोई इशू नहीं है,
Visible, sir.
थोड़ा देखो, क्योंकि फ्रॉम माय साइड इट इज ओके एंड सम ऑफ द पीपल आर एबल टू सी, दैट मींस इट इज ओके, एंड फॉर योर साइड आई थिंक योर नेटवर्क इज नॉट दैट मच गुड. So don't worry, recording will be there, no issue. So again, what we need to do here, gray screen is there, we cannot write anything. So after this, you need to go to file and press on the new file. Have a look. As soon as you press new file now, see this type of screen will be there. Now we can write a program. So now before going to this program now, do one more thing. What is that more thing, sir? We have to save this file. When you press save now, same folder will be open. See, 11 p.m. B11. So now we need to save this file again. Demo, let me save another name, take program 1. Program 1. Please remember that after writing program 1, dot write ASM. ASM means assembly language. If you want to write a program for C, you have to write program dot C. So now I'm going to save this. So whenever you save this, after saving this, you need to do last important thing before writing a program. What is that last important thing? Whatever program you have just saved now with the name program.asm, that program, that save file you have to add. Where to add, sir? You have to add in source group. So on the source group, you have to click write. Now, when you do right click now, there is one norm that is called add existing file to source group. Just now you have saved now file that is existing file. Now I am going to press on the existing files. So this type of screen again will be visible. Just now what we have saved program.asm. So this is the program.asm. Now you have to add this program.asm. So here is this add. Now you whenever you press add now, please have a look. Source group, nothing was there now. As just as you press add now, what happens? See, when you do add now, see in the source group, that file was added. See, in the source group one, same file which you have saved now program.asm was added. Now after doing this, you can write any program what you want. So this is the procedure you have to follow before writing anything in the Keil software. Hope this is okay. Getting my point?
Yes,
Yes,
sir.
sir.
Good.
Yes, sir.
So now I'm going to write a program. Just see whatever I have taught you in the class, just I'm going to do that only. Let me write a very beautiful program. Whenever you want to start a program, start program means org. Org is the assembler directive which you need to write to start the program. From where you want to start the program? Sir, I want to start the program from 000h and I want to end the program. So in order to end the program, you have to write end. Between org 000 and between end, you need to write a program. So first of all, let us see what we have studied. The first addressing mode what we have studied, the immediate addressing mode. Let me write that instruction. Move a comma has 20h. So that means this is the first addressing mode which we has been taught to you in the class. What is the meaning of this addressing mode? Directly the content, because hash is the before 20 we have written hash. That means this is data. This 20 data is going within the A. Now let me write the next addressing mode, the register addressing mode. Move something into R naught. What is something? A. Whatever content A have, you have to move that content into R naught. This is called register addressing mode. So now I have used two lines, which is one is immediate addressing mode and another one is register addressing mode. Both these lines was written. Now I want to tell you to execute these two lines only. So the meaning of the first line is A will get 20h and the second line means 20 will go into R naught. Similarly, if suppose I want to write something more, so what do one thing? Add comma add a comma has 30h, and whatever result will be going, that result will be in A. Now move that result into R1. So if you see the line has been written, each line meaning we know. So now in order to execute this file, we have to do again so many things. What are those so many things, sir? So first of all, save, and then if you see here, this is build. translate. What is the meaning of this translate? Whatever you have written now, this program need to be converted or translated into machine code. So first of all, we need to press translate. After the translate, if you see that at the bottom, there is no error, no warning. After the translate, you need to do one more thing. This is called build. After pressing the build, you have to again press the rebuild. That means translate, build, and then rebuild. After doing translate, build, and rebuild, you have to go to the run button. See, this is the run button. So now I'm going to run this program. So after pressing the run button, see what will happen. One message will come. What is the meaning of this message? The meaning of this message is this Keil is free version. In free version, the program whose size will be less than 2 KB, that only will be executed, because this is a free version. If you want to execute bigger program, much more larger size, then you have to buy the updated or the pro level Keil version. So yes, our program is very small, so it is under 2K. So I will be pressing OK. Just after pressing C, what is this screen? If you see this screen, you will be understood what I am talking about. Visualization of microcontroller. C, R0, R1, R2. These are the general purpose register visible. Similarly, A register, B register, stack pointer, DPTR, program counter, and C, program status word, PSW. PSW, parity flag, overflow flag, RS flow, RS0, RS1, F1, auxiliary carry, and all those flags will also executed. Now, if you see, this screen will be visible. Now, if you see this arrow now, have a look, this arrow. What is the meaning of this? Your program is at this level now. This is not executed. Now, arrow means, on this means, if you press run now, this line will be executed. So please let us see what is the meaning of this line. The meaning of this line will, A will get the 20. Now I am going to execute this program line by line. So if you want to execute the program line by line, this is the option to execute program line by line. If you want to execute the complete program, this is the program to simulate all the program in one go. But I want to show you the program line by line. So I will be following this. As soon as I will be pressing this now, the line move a comma hash 20 will be executed. When this line will be executed, a will get 20h. So please have a look on the 20 register. As soon as it will be executed now, this content should be modified, and this content will be 00 right now. After the execution, it will be 20. Let us see it will happen or not. Now I'm going to execute. See, I have executed one. Now the line moves to, this program moves to second line. Now if you see, the content of A is 20. In the second line, what is the meaning of? Whatever will be in A will go to R0. Okay, let us see. Right now R0 is 0. So after executing this line, whatever content will be in A, that will go to R0. Okay, see, whatever content was in A, that was transferred to R0. Good. Now this fourth line is, after executing fourth line, whatever content will be in A, that is good, not a problem. But that A will be added to the immediate content, that is called 30h. So the result will be 50, and that 50 will be inside A. So now let us see what will happen. Have a look. After executing the add a comma 30h, if you see the content of A, the content of A is modified to 50h. That means it is correct. Now what you want? You want to move this content of A into another register, that is called R1. Right now R1 is 0. After executing this line, The content of A, that is called 50, will go into R1. Let us see if this will happen or not. Now, see, after executing this line, R1 will get 50H. Hope this is clear and easily visualizable. Is it correct to all of you? It is understood. So
Yes, sir.
this is simple as 8086 now only. How to see, register and all those things. The only thing is that key some procedures you need to follow. First of all, you need to create one project, that then you have to save that project. Sorry, after creating that project, you have to create a file. After creating a file, you have to save. After saving, you have to add one file then to the source. After adding and all those things, you need to write a program. After writing a program, you have to debug the program. After debugging, you can execute or run this program one by one or line by line. Sorry, line by line or complete. So if you want to see line by line what is the meaning of this, you can do like this only. Is this clear to everybody?
Yes, sir.
Yes, sir.
Good. Good. Now what I am going to do, now you must be thinking, sir, I want to see something which we have visualized in the 8086 microcontroller programming, my 8086 microprocessor programming. Now let me show you in this program only. I'm going to delete all those 4 lines. I'm going to show you the memory. First of all, please tell me, within the microcontroller, we have RAM and ROM. ROM can only be read. It cannot be, by writing a program, you cannot write anything in the ROM. But if you want to store something in the ROM, which you want to use in the program, how you will do that? See how I'm going to do that. See what I'm going to write. org 2000H. After this, I'm going to write, see, very beautiful line, data, or I'm going to write deep. After writing deep, what I'm going to write, have a look. 01, sorry, 11H, comma, 22H, comma, 33H, comma. Same as in where what we are doing in the 8086 programming, we are giving one variable name. Here I am going giving the name deep variable name, and after writing deep, sorry, one thing we have missed, if you remember, db, data byte. So deep is the variable name, data byte is the variable type, and whatever the content, 3 content you have given. Now please tell me, one will go where? One will go to 2000. Two will go to 2001. Three will go to 3000 2003. Why? Because you have written org 2000 here. Now if you modify this as a 3000, so what is the meaning of this? Whatever written inside this org and in between that, the same will be stored. For example, one will be stored at 3000, and 3001 222, and 3002 33. So this is the way how you are going to write something, or store. Sorry, we cannot say write. How we are going to store something in the what we call room. Now, how you are going to read, how you are going to read the room, just by writing this beautiful line. Please have a look. D dptr, sorry, move dptr, move dptr. What you want to move into dptr? Please have a look. Deep, and then move C. If you remember, in order to read something from the room, you need to write move C. What, where you want to move this content? In the inside A, comma, at the rate A plus dptr. Please, can you tell me what is the location of dptr right now? 2000. What is the content in A? Let me take the content in A, move, or we can say that uh, clear A. So please, can you tell me what is the content in A? The
Zero.
content in A is 0. What is the content in DPTR? Deep. Deep is we starting from where? 3000. So right now in DPTR have value 3000. So what is the meaning of this line? The A will get the content present in A plus DPTR. A plus DPTR means 3000. 3000 have what content? 3000 content is 1 1. Now, if you want to move this content into A, so what you will do? We have to
Element
move, we have to write like this. Move A comma as 01H. So right now, what is the content in A? 01. So what is the meaning of this line? The meaning of this line is 01 plus DPTR, that means 3000. 3000 plus 01 means 3001. So 3001 location, what is the content? Content is 22. So this 22 will go to A. So now whenever this A will get the content, now I want to move that content into R naught comma A. So whatever content will be in A, that will be moved to R naught. Let us see or visualize this program. After visualizing this program, you will understood what I am talking about. Okay. So again, the problem is very simple. So we need to do like this. Same, everything is done. So first of all, we have to press on the debug. After debug option, you will get again translate, then build, then rebuild, and then as soon as you will press debug now, again the screen will be visible to you. So now after this, see. Now again your program will be at line move dptr comma hash deep. So now everything is clear. See, all the resistance are right now clear. Now what you want to see, truly see whether whatever you have written here is actually correct or not. So let me show you. This is the memory. If you see like this, here is the screen. Call stack, and if you see here, there is memory 1. If you press on the memory 1, one screen will be visible, and see here it is address. So where you have saved everything at the location 3000H. So when you press 3000H now and press enter, see, whenever you press 3000C, what is the content? 11. What is the content? 22. What is the content? 3. So that means whatever I have told you now, if you want to store something in the ROM, so first of all, you have to write those things in the ROM. Yes, I know 3000 location will start from with a name that is called deep. Deep variable, deep is the variable name, and 11 is the content of 3000. 22 is the content of 3001, and 33 is the content of. So, but in order to read this value, we cannot read this value by writing a simple line. We have to read this line by writing a very beautiful ROM instruction that we call move C. Move C a comma a plus dptr. So whatever content you want to read, you have to provide that value into A. So for example, in A, what we have provided? We have provided 01. So 01 means 3001. So 3001 location content is 22. So that 22 will go to A. Now at last, what we have written? The content of A will go to R naught. Let us see whether what we are talking about, what we are written in the program, is this correct or not. So first of all, I'm going to execute the first line, that is called C dptr. So if you look here, what is the content of dptr? The content of dptr is 00. Right now, this line is not executed. Now, once it is executed, dptr content will be modified to 3000. Let us see it will be modified 3000 or not. So, executed. As soon as it is executed, see the dptr content was modified to 3000. If at this location you have written down 3000, 5000, 8000, any content you write now, dptr will be modified to 3000, 5000, anything. Now, second line. Second line is that A will get the content 01. Okay. So let us execute this line also. See, after this execution, A will get 0, 1. Correct? Absolutely correct. Now this line is very, very important because I want to show you how to read the data from the ROM. So the meaning of this instruction is A will get 0, 1, or A will get the content of from the location of 3001. From 3001 it will get the content, and 3001 content is 22 as it is clearly visible in the memory. See, this is the 3001. So let us see whether A will get 22 or not. So I'm going to execute this line. Executed. See, as soon as it is executed, the A will get 22. So that means whatever you are talking about, it is correct. Now after getting the content into A, that is 22, you want to move this content into R naught. So let us execute again. Now see, R naught is 22. So that means this is how you are going to read the from ROM also. So reading from ROM can be visualized from memory one and all those things. And similarly, all those are not R7 register can be modified, written here, there. And now you must be talking about these R0 to R7 is nothing from the, is basically from the bank 0 only. So if you want to make it bank 1 or bank 2, bank 3, so first of all, after this line, what you need to write, you need to write like this. You need to write two line. Set the bit, which bit, program status word. Please have a look in the program status word. See, this is the 00, that is parity, and this is auxiliary carry, auxiliary carry. This is R naught and RS and R naught, sorry, RS and R1, I think this one. So you need to modify, set these two value, RS0 and RS1. So we can write this line PSW.73.4. Similarly, when you set this now, so this will be only R0 and R7 only, but this will be from bank number 2 only. So this is how you are going to see, write, store data in the ROM also. How you are going to read from ROM? Reading from ROM is like this only. Now can you tell me? Now I'm going to write again one more beautiful thing. See, so suppose this is your class, that is B11, B11 or D21 slot class. So I'm going to write a name of that variable is this one. So now for your class, I'm going to store something in the memory, and that something is nothing but 99H. So this is the how. So please tell me, after this deep variable, I am going to write again one more variable with the name B11, D21. But again, this B11, D21 location is very, very clear because you are writing in 3000, 3000 content is 11, 3000 1, 3000, 3001, and then 3003. After that, whatever you want, right, that content will go to 3004. Let me see whether this is happening or not. So exactly speaking, here you will get 99. Right now this is 00 only. So let us see what you are talking about, it will happen or not. And after that, I am going to write one more line. See, move, sorry, move A, comma, 0, 0, 0, 0, 1, 0, 2, 0, 3, 0, 3H, and then I'm going to write move C, A, comma, at the rate R, sorry, A plus DPTR, TR. Let us see what will happen. So first of all, again, debug. When you do debug, build, translate, build, rebuild, again debug. After debugging, you will get an screen, and if you see the screen and see the memory and memory location, this 99, see the content 99 is there. So whatever you have written, absolutely what is the meaning, you are getting same 8086. If you see that, yeah, one variable, two variable, line by line it will go now. So like this only. Now but I want to execute this line again and again. Let me execute one line, second line, third line. I'm interested in this line now. This line I want to execute. What is the meaning of this line? A will get 03. Okay, so A will get 03, and then I am going to execute this line, and A will get 1 1. Thinks this is wrong now. A will get 1 1. Why A is getting 1 1? This line is executed, no. Or okay, again, oh, sorry. I am written here also. I am written here also. I need to delete these two, three lines. Sorry. Now you can say that. We are confusing our microprocessor giving A different values. Now again, rebuild, debuild, and then debug. And after debugging, this you will get, this is the program. Now I'm going to execute. The PTR will get 3000, correct? And after this, we will get 0. A is not getting 03, yeah? Sorry, why A is not
So
getting 03?
you need to put the hash.
Correct.
फिर हैश
Yes. Good. So why not getting, you got it. So like this only. So again, I need to do debugging, again build. Whenever you are changing the program now, you have to translate, build, rebuild, and then debug, and then execute. See, execute. A will get 03, and then 03 plus dptr will get 99. See, A got the content of 99. So this is correct. So likewise, you can save any variable in this org. Deep is the one variable, b11 is the one variable. For example, if I'm going to give the name A variable, A also is clear. We can give the another variable like same B variable, and then so on. Yes, please tell me.
सर एक छोटा डाउट था जैसे ओ आर जी 00 ओ आर जी को 3000 डैश दे दिए मतलब वो जो हम लोग का ओरिजिन है
हाँ हाँ,
वो ओरिजिन मतलब डिसाइड कर रहा है कि डीपीटीआर में कितना वैल्यू जाएगा
ORG ओरिजिन नहीं है, और ORG
हाँ
ORG
तो
के, हाँ, यहाँ से आप चाहते हो कि जैसे आपने ORG लिखा ना 3000, तो इसके अंदर जैसे होता नहीं, तो कोड सेगमेंट के अंदर जो भी लिखते थे वो कोड सेगमेंट में जाता था। तो
यस
जब तुमने यहाँ पे ORG 3000 लिख दिया ना, तो 3000 के बाद वाले जितने लोकेशन होंगे वहां पे ये स्टोर हो रहा होगा। और अगर आपने यहाँ पे जैसे ORG 00 लिख दिया ना, तो 00 के बाद ये जो लाइन इसमें लिख रहे हो ना, वो 00 के बाद जा रही होंगी। तो अगर 00 के बाद जा रही होंगी और लगभग वो 3000 तक पहुंच गई, तो 3000 के बाद वो लाइनें 3000 में नहीं जाएंगी, फिर वो जो थ्री, ये दो लाइनें खत्म होने के बाद जाएंगी उसमें।
मतलब सर अगर हम लोग ओ आर जी 3000 डैश के बाद अगर कुछ भी लिख रहे हैं तो ओ आर जी 3000 डैश एक ऐसे लाइन की तरह वर्क कर रहा है कि वो बता रहा है कि उसके
हाँ
बाद
हाँ,
वाला जितना भी लोकेशन है
तो
सब 3000 के बाद आएगा
करेक्ट, तुमने मान के चलो वो एक तरीके से सुपरफिशियली डिवाइड कर दिया अंदर, जैसे कोड
हाँ मतलब
सेगमेंट
वो
में।
डिवीजन कर रहा है मेमोरी का
करेक्ट, वहां पे लिख देते थे। यहाँ पे ORG से डिवाइड करते हैं कि कितने पार्ट बनाने हैं, वो तुम्हारे ऊपर डिपेंड करता है। अब मैं अगर यहाँ पे ORG 3000 या 2000 लिख दूँ, मुझे पता है कि ये प्रोग्राम ज्यादा बड़ा नहीं होगा। जैसे ये जो लाइन है ना, ORG 0 से लेके, ये ज्यादा बड़ा प्रोग्राम नहीं है, तो मैं क्या करूंगा, ORG यहाँ पे 1000 से स्टार्ट कर दूंगा। लेकिन मैं फॉर द सेफ साइड में क्या कर रहा हूँ, क्योंकि हमें पता है कि FFF तक जाता है ना, तो मैं फॉर द सेफ साइड लेके चल रहा हूँ, यहाँ पे 4000 डाल दे रहा हूँ कि मान लो इसके अंदर में जो भी प्रोग्राम बड़ा भी आ गया, तो बहुत बड़ा बड़ा होगा, तो 4000 लोकेशन से ज़्यादा नहीं होगा। तो मेरे लिए सेफ साइड है, क्योंकि ये जो वेरिएबल मैंने सेव किए वो रखे रहेंगे। तो ये भी बहुत अच्छा है। और दूसरी चीज़, अगर अच्छा ऐसा करना चाहते हो तो ये भी कर सकते हो कि ORG 00 से स्टार्ट कर दो, और यहाँ पे वेरिएबल दे दो A DB और 01H, दूसरा वेरिएबल B A DB और 22H, ये भी कर दिए। और इसके बाद जानते क्या लिख दो, ORG फिर से लिख दो 2000H, तो ठीक तो है। अब वो 0 से लेके 2000 के बीच में तुम्हारे पास यूज कितनी लोकेशन करने की, सिर्फ दो।
दो
तो अगर तुम्हें पता है दो लीज है, तो यहाँ पे तुम स्टार्ट कर सकते हो 003 से भी कर सकते हो, ये भी कर सकते हो 003 से भी कर दो, कोई प्रॉब्लम नहीं। तुम्हें पता है कि मुझे दो ही लोकेशन तो मैंने यूज की है, 000 और 001, तो आप यहाँ से 002 से स्टार्ट कर दो, तो कोई भी स्पेस खराब नहीं हुआ तुम्हारा।
ओके सर
हाँ, ये प्रोग्राम होगा, यहाँ पे प्रोग्राम लिख दो। तो अगर देख रहे होगे तो 8086 की तरह ही है, नथिंग चेंज, बस ओनली थिंग कि हाउ टू रीड मेमोरी रोम, मैंने वो बता दिया। हाउ टू राइट अ प्रोग्राम, मैंने वो दिखा दिया। नाउ आई एम गोइंग टू राइट अ प्रोग्राम टू ऐड टू 8 बिट नंबर। जनरली हम लोग यही करते हैं ना, 8 बिट एडिशन, मल्टीप्लिकेशन, डिवीजन। सो आई एम गोइंग टू राइट दिस लाइन, सो प्लीज हैव अ लुक। just doing this program for you. This is the last program for today's class. So I'm going to start the program from org 000h. Good. Again going to put the int, and then I'm going to write a program inside it. So I want to add two 8-bit number. Okay, so move a comma has 30h, and then move r naught comma has 20h. Now both are added. Now I'm going to add these two number. Add r naught comma a. Yes, we can add r naught a, but we cannot add r naught into r naught comma r1. But this addition is possible. So whatever sorry, this we cannot write. We have to write here a and here r naught. Okay, so whatever content will be go in C inside A. So whatever content you will get in will go inside A. So I want to move that content into R1. What is A? So this is the program I am going to write. The result will be visualized where? Please tell me. After reading this
Sir,
program,
R1,
we all know what the result will be in R1. What will be the result? 50. So let
50H.
us 50. Okay, so let me see. So first of all, what we will do, again we have written another program now. So we need to do
Revealed and
debug, and then translate, then build, then rebuild. After rebuilding, again you need to do debug, then okay. Now the screen will be visible. Now I'm going to execute the program as a whole, not step by step. So as a whole, we need to press on this run to cursor line. This is the whole program will be executing in one go. So after executing the program in one go, ultimate content will be in R1, and that content will be 50. Let us see. See, if you see, the result is clear, absolutely correct. Whatever you have expecting, the result of R1 is nothing but 50 only. So this is how you can write a program to add 8-bit number, how to write it. So now for lab manual related thing, you can write a program. For example, in this board only you can execute this program, and if you want to write in the copy itself only, no problem. But I want my all my student to be familiar with this 8051 Keil software also, because it is very beautiful to visualize all those things. Acha, you want to see that carry and all those things. So in the last class, if you remember, I have taught you something very beautiful. So let me revise that. You will enjoy. A comma 02H. What is the
A
content in
comma
A? Sorry, A comma. What is the content in A? 20H. Correct.
20H.
Now I'm going to write. If you remember the last class, rotate, right, circular, A. Remember keyboard programming,
Yes, sir.
column, first line. Now let us see what is the meaning of this. So in this case, we need to see the program status word, because in program status word only we are going to see the carry. So if you see what is the content, 20H. So 20H means 00, 10, and 40. Correct? So let us see when the carry will be generated, when there will be carry, when there will not be carry. So I'm going to execute first of all debug, because new program is written. So then translate, then build, then rebuild, then again debug, then okay. Now see, here I am interested in program status word, so place on the plus. So this is the program status word. So now this is the program status word. So I'm going to execute line by line. So A will get 20. See the parity bit in the program status word. If you see the parity bit is 1. Why parity bit is 1? Because this is odd parity or even parity. If you see the result
Even
A,
Even
A is
parity.
basically 0010. So 001 is the only one. So this is odd parity. So 1 means odd parity, 0 means even parity. So now I'm going to
Yes.
execute. One time, if you execute, it still carries 0. What is the meaning of this? If you see 0010, So one time rotation means now it is at the location 0001. Now second time rotation, still it is not at the highest point. Third time rotation, fourth time rotation, and fifth time rotation, and sixth time rotation. So if you see, do on keep on, it's not executing here. Rotate right circular. Why not getting rotated? Is there any
Sir,
issue?
loop.
Loop, maybe rotate right circular A. Oh, after this is program is ended, yeah. Okay. Sorry.
सर
We need
रिजल्ट
to
स्टोर करना पड़ेगा
शॉर्ट जंप करना पड़ेगा.
जीएम
हाँ, कहाँ करना पड़ेगा?
SJMP, sir.
Done. Now it is correct. So short jump. Sorry, short jump
Sir,
spelling.
it should be SJMP.
Short JMP jump. Done. So again we have modified some programs. So again we need to do debug, and then translate, then build, then rebuild, then debug, then okay, and then now this is the screen. So first time execution it will move 20, and then second line it will go to rotate one time, and then second time again, then fourth time, fifth time, sixth time, again rotates, again rotate, again rotate, again rotate, again rotate, again rotate. Now see, after so many rotation, if you see, carry 1. Getting my point or not? And if you see now, if you put 0010, so this 1 will be, you will get carry after how many rotation? 5 times. Because first of all it will go to fourth position, then it will go to fifth position, then it will go to sixth position, then it will go to seventh position, at last it will go to eighth position. And when it will go to eighth position, that is nothing but the carry. So like this we are going to do the carry. See, carry is generated, and that is why we have written one line, beautiful line, if you remember. After this, in the keyboard programming, we have written jump on no carry, and that is why, because this, after this line execution now, we need to see the carry. After each rotation you need to verify the carry, because carry will be modified after executing this RRC. RRC means rotate right circular through carry. So this is the meaning of this is rotate right, C for circular, C for through carry. So you cannot move the only circular, but you have to move the result through carry only. So this is the beautiful instruction. So you can write a program, that is keyboard programming also here. You can simulate also, but the only thing is that you cannot be able to visualize, because keyboard and microcontroller interfacing require two softwares. One is Keil, where you write a program, and another one is Proteus, where you can connect microcontroller with the keyboard. Virtually, keyboard will be available to you. Virtually, microcontroller is available to you. Virtually, you can connect both these things on the software, and in that case, you need hex file, and that hex file will be get. Now you must be wondering, so from where we will get the hex file, na? So let me show you that. So if you see like this now, this is the target. See target. If you press on the target one now, you will have to go the option for target one. Option for target one will open one window. In that window, if you see the output, and in that output, if you see if you want hex file or not. So if you don't want hex file, you need not to check this box. And if you want hex file, you have to click on this and then execute the program. Then you will get a hex file. Now it's your job to go and check from where you will get the hex file and from where you will get copy. This is the method how to create a hex file. And now it's your assignment. If you want to see hex file, but hex file will be required in Proteus only, so no need to worry about this hex file right now. But you must know that hex file, if somebody asks you, can you give me the hex file of this program? Similarly, sometime what happen now, you need a hex file for when you are writing a program in C. Na, in C also, whenever you are writing a program, for that also you need a hex file for some other applications. So if you will write a program in C also, there is a possibility to write a program in C also here. Write those program in C, and for that program, if you want hex file, for that also you will get a hex file, and then you can give that hex file to anywhere, and you can use that hex file. So it is very beautiful tool, and that is the reason why I'm worried about. I want you to learn these things, because sometimes whenever people will ask you, can you provide hex file for C or assembly language? Then you must be saying, sir, what is hex file? From where we will get hex file? And what is the meaning of hex file? What we will do with the hex file? This type of question will be there. And one more thing is that people will be worrying. So is it possible to write a program in C only, or is there is a possibility to write in assembly language? Both the things are possible. Only one thing, if you remember my point, while saving that file now, you have an option that is S or no. If you press on S, you have to write the program in C. And if you have to write the program in C, then you have to save that file which is with the name .c also. Here we have done no, and that is why when we have saved the file name, that is called program.1 asm. So that is the things which we need to take care of, and then you can do whatever you want to do. Suppose if you anybody asks you, can you generate hex file for me? Yes, I can. Just only thing is that before writing a program, before executing a program, go to the setting and check the checkbox that is called create hex file. After that, you will execute a program, and then you will get hex file. Now the only thing is left to you, how to copy that hex file and give to the other paper which has been asking. So that part you can do if you want. And this is a beautiful, simple assignment. Only 1 minute things. Because I have already told you everything. Is this okay to all of you? Please let
Okay,
me
sir.
know. Is it
Yes, sir.
clear to everybody? Now you can
Yes, sir.
visualize your own. Good. So tata, bye bye, good night. First of all, a very thank you to all of you, those who have joined this class, because I know it is very tough for you to join this class, but you joined, and it basically, I'm very feeling very happy. 80 people have joined right now, and thank you, yeah, thank you very much, because I love teaching, and if my student respond like that now, I enjoy teaching a lot. Thank you, thanks a lot. Tata,
Thank
bye bye,
you.
good night. See you.
Good night, sir.
Good night, sir.
Good
Good
day.
night. Recording will be
Nice
shared
one.
also for those who have not joined yet.
Good
Thank
night,
you,
sir.
sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Tomorrow I'll be waiting.